Hi, welcome to the channel. I'm Mrs. R. Let's do some math. Today we're talking about the real number system. Now, pretty much every number that you know at this point in your life, if you are starting an Algebra 1 class or course or process here, pretty much every number you're aware of is a real number. But we can break all those real numbers down into different groups with different names, and we can classify them. And if you've just gotten an assignment from your algebra teacher about classifying sets of real numbers, this is going to help you. So the first set of numbers that you actually learn when you're first growing up is called the natural numbers. And we emphasize these with this fancy N here. Now these are your counting numbers. Like 1, 2, 3, 77, 529, etc. So these are numbers where you see a group of things, you can count them, that's a number that you get. Pretty early on, you realize that there can actually be an absence of things. So when you're counting things, sometimes you have them, sometimes there's nothing, and then we include 0. So whole numbers are going to be our natural and 0. So then we get 0, 1, 2, 3, etc., etc. Now, whole numbers don't really have a special letter that we use. So if you're abbreviating for an assignment or something, you might put W, you might put the word whole, whatever works out for you. Then you get into about middle school, and you learn that we can use negative numbers to represent taking away or being less than 0. And then we now have integers. And we give them this fun Z as their little label that represents the set of all integers. Now, this is the whole numbers and negatives. So when we're talking about integers, you could have negative 42, negative 3. 0 is still included. You get positive numbers. So the negative numbers, 0, positive numbers. So positive and negative whole numbers is sometimes how people describe integers. Then the next one, once you realize that, well, sometimes we don't always have those whole pieces of numbers, even when we're taking them away, we get into rational numbers. So rational numbers, the word comes from ratio, because these are numbers that can be represented using a ratio. Now, another name for this ratio, like A over B, that's a ratio, is a quotient, because as we know, that over bar, that fraction bar, also means division. So we can also say this is a quotient style setup for a number, and that's why we get the Q as the rational numbers. Special little abbreviation. So what we have here, this is integers and partials. Really, it's and fractions, but we can use decimals in there too, because decimals are just a way to represent some fractions. Now, these would be the repeating decimals or the terminating decimals. So just like I could use 3/5, the decimal equivalent to that is 0.6. So both versions of that number count as rational numbers. That is a rational number no matter how you write it, as a fraction or a decimal. 1/3 is a rational number. You can write it as a ratio, as a quotient. You could write it as a decimal, 0.3 repeating. Now, this is not a terminating decimal. It does keep going forever, but it's a repeating decimal, so that would still count as a rational number. Now, if we say there are rational numbers, then you might expect that there are also going to be irrational numbers. Now, irrational numbers, we're going to scroll and move this down a little bit. Irrational numbers are ones that are not whole numbers, right? They're not integers. They don't fit in any of those categories we've already said yet, but they can be decimals. They're decimals that continue going on and on and on. So These are continuing decimals. Now, we've had a lot of overlaps so far in our numbers, but the irrational numbers do not overlap with anything we've talked about already. This is a completely separate set. We're going to draw a little diagram here in just a minute to show kind of what that looks like. But irrational numbers, these are continuing decimals. If you've ever tried to divide something out on your calculator and it just fills the screen with a bunch of random seeming digits, it was probably an irrational number. Now, the most famous irrational number is pi, and you may already know that it's approximately 3.14, but pi is actually a decimal that keeps on going forever and ever and ever. They haven't found the end of it. They believe it doesn't end. It is an irrational number. We use the symbol pi to represent that never-ending number. Now, there are other irrational numbers. For example, would be like the square root of 15. The square root of 15 is not a whole number. 15 is not a perfect square. And if you actually tried to find the right decimal so that you could multiply it by itself and get 15, you would have to keep trying and trying and trying. You could get really close to 15, but you would never find the perfect decimal because the perfect one actually keeps going forever and ever and ever. So those are irrational numbers, the ones that we represent with Greek letters because we want to represent the full value, or the square roots that are not perfect squares. All of these that we've talked about so far are called real numbers. So that's everything. That's the full scope. Now, just kind of a side note, if we say that these are real numbers, yes, that does imply that there are such things as non-real numbers. It's what we call imaginary numbers, and kind of in that realm, complex numbers. But that is not something for an Algebra 1 level. We are going to talk about that later in Algebra 2, kind of bring that in maybe with quadratics later in the year. But right now, as we're getting started, we are just talking about the real numbers. So we're just going to kind of not worry about those. So all of these are real numbers. Real numbers are like the big, here's the whole, everything you know about numbers. These are all real numbers. Now, in there's a chunk that are irrational, which means this chunk up here, these are rational. Now, in that rational group, some of them are integers, some of them are not. So we can start to kind of break this down. Maybe here's one where we say, okay, these are the integers. We get that fun z for the integers. And with the integers, some of them are considered whole numbers, but some of them are negative numbers, right? So we could make another little spot and say, okay, these are the whole numbers. But even then, 0 doesn't count there. 0 is a whole number, but it doesn't count as a natural number, so we can make even a smaller one that's for the naturals. So likely if you've been assigned something that says, hey, work on classifying numbers within the real number system, they'll give you a number and you'll have to figure out where on this map it actually fits. The idea is, let's say you get an example and it's -15. So you think about that and you're like, well, it's not a natural number. It's not a counting. I can't count a pile of -15 things. So it's not natural. Technically, it's not a whole number, because those, remember, as it was defined, those are the natural numbers in 0. But it's not a fractional number either, so that's going to make it an integer. So that's the most specific. But if it's an integer, look where else it is. If it's an integer here, it's also part of the rational numbers, but those are also part of the real numbers. So you would end up in your answer, you'd have your z, or write out integers. You'd put your rational or your q, if you remember that that's what it is. You can write rational. And then you'd also have your fancy r for being a real number. Now, pretty much anything on any worksheet that you're given for an Algebra 1 is going to be real numbers. So you're probably going to have an r in all of them, but just watch out for the rational. Either write out rational or use the q versus the real r. Something like the square root of 36, you have to be kind of careful with. We talked about square roots We talked about it with the irrational side of those, like the square root of 15. But think about if we simplify that, we know what the square root of 36 is. That's just 6. So then instead of trying to say this is irrational because it has a square root, then we actually get to say, well, no, this is a natural number. This is a whole number. This is an integer. This is a rational number. And it's a real number. So you have to be careful. Make sure that you are checking to see if your number is fully simplified before you analyze it. But in general, what you need is either this little table to show you how all those sets of real numbers work together, or you need kind of this list to show how they're defined. So whatever it is that helps you, there you go. If you think this video was helpful for you, please like so that we can get some more videos going. If you still have questions, leave a comment. If you want to see a different concept, leave a comment. I'm Mrs. R, and this is Mrs. R Does Math, talking about the real number system.